Good morning or good afternoon. It's Miss Bauer, and today we're back to talk about spheres. Now, spheres are a different shape, mainly because spheres don't have a base. So, like if I just look at this exercise ball, there's no base. And so spheres are a little bit different. If we go take a look at our formula chart, for a sphere, there's only total. Spheres have no bases, therefore there's not a lateral formula. And then if we look, there's only one thing that we need for a sphere, and that's just the radius. Whether we're doing surface area or volume, we really only need the radius in order to figure out these problems. Now, you do have to be able to tell different parts of a sphere. And so just kind of going through, I'm going to draw some little pictures here. Most of you hopefully already know some of this stuff. But the radius goes from the center out to the edge of the circle. So that's the radius, that's the radius. It doesn't really matter where I put it, but it doesn't go all the way across. So that would be the radius right there. It does not go all the way across. And most of you think of the radius as half of the diameter. So the diameter would be the one that goes all the way across. And it might go that direction. It could go that direction. It doesn't necessarily matter, but the diameter is the whole, and then the radius is the half. So the diameter is the one that goes all the way across, and the radius is half. So if the diameter is 10, the radius is 5. If the radius were 7, then the diameter would be 14. And for spheres, we want the radius. We always want the half one. So we have to be careful if they give us the diameter. Okay, now a hemisphere is a half sphere. So a hemisphere is half of a sphere. And most of you are really familiar with what a sphere is. And then we're going to draw a picture to help us figure out what the great circle is. So the easiest way to kind of draw a picture of a sphere is to draw first, just start out with the circle. And then we need a center for it. And so some people like to do the center first and then try to do the circle around the edge. It doesn't quite matter. But then what we're going to do is we're going to draw this kind of oval looking eye. So I'll typically make the back side or like the top side dashed and then the front side solid. And then that's how we get our sphere. That's it. So pretty much draw a circle, give it an eye, and then make the top of the eye dashed and the bottom of the eye solid. Now, the great circle is the largest part, the largest kind of wraparound. For example, the great circle of the earth is the equator. And so that great circle is what actually divides, like here's our great circle. Your great circle is it's actually what divides your sphere into hemispheres. So the great circle is like the largest wraparound part of it. It's like up here, this would be a lot smaller than like this right here, but the widest part would be around the center. That's your great circle. Think of the equator for the earth is the great circle for the earth. So that great circle, once we know the radius for the great circle, well then we can figure out the dimensions for the sphere. So if a workout ball has a diameter of 26 inches whenever it's fully inflated, approximately how many cubic inches of air can it hold? Now, this doesn't tell us exactly what it wants us to find, but we've seen surface area and we've seen volume before. So whenever it says cubic inches, air that it can hold, that's our clue that this is going to be a volume problem. So if we go look at our volume formula for a sphere, if we go back and look at it, it's 4/3 pi r cubed. That 3 is cubed. So volume for a sphere would be 4/3 pi r cubed. So r is the radius. If I go back, it told me that the workout ball had a diameter of 26, meaning that the radius would be 13. So I'm going to go volume equals 4/3 pi. I'm just going to plug it in. 13 cubed. And if we leave this in terms of pi, remember it's the opposite of what we think. It means we don't type pi into the calculator. We do everything else. So 13 cubed would be 13 to the power of 3. And the way to do that in the calculator is you'll type in 13. Underneath clear, you're going to see this key right here. This is called the caret key. And then you're going to type in the number 3, and it's going to look like this. So you want to find this caret key to do cubed. And that's over on the right side of the calculator underneath clear. So you're going to do 13 caret key 3. That's going to give you 13 cubed. Then I press enter. And I know that 13 cubed is 2,197. Then to do 4/3, all I'm going to do is just multiply by 4 and divide by 3. So I'm just going to do times 4 over 3. So I'm going to take that number, 2,197 times 4, divide by 3. And it gives me 2929.3 repeating. So that's 4/3 times 13 cubed, but don't forget I took the pi out, so I'm just going to throw it back in to leave it in terms of pi. And our units would be inches cubed. And that's it. So while the formulas for the spheres I think are a little bit easier, we just have to be really careful with those calculator skills and making sure that we're typing in everything correctly and that we're being very, very mindful of the cubic and the squared and all of that. Now the next one says how much material is needed to make the workout ball above. Well, how much material is needed to make it? That wouldn't be volume anymore. That would be surface area made with a very thin piece of plastic. So if we go and we look at our formula chart for surface area, the surface area of a sphere is S equals 4 pi r squared. So surface area of a sphere is S equals 4 pi r squared. It's the same workout ball, so it's the same numbers as before. So it's going to be now 4 pi, the radius is 13 squared. And now I need to figure out what's 13 squared, and then I like to multiply it by 4. So I like to go a little bit backwards in these problems because we do exponents first. So I'm always going to do this part first and then deal with the rest of it. So the exponents first would be 13 squared is 169. Multiply that by 4. So the surface area would be 676 pi inches squared. Now, these are our answers in terms of pi. If we wanted to know what it is as a decimal, then I would actually take it and just multiply it by the pi key. So like if I said round it, then that would be 2,123.7166. It keeps going. That's with pi actually in the calculator. Now, if we move on, this problem says that Carla uses 100 pi of batter to make each cake ball below. What is the radius? So now I'm going backwards. Well, if she uses 100 pi of batter, would batter be the surface area formula or would I use the volume formula? And if we're talking about cake batter, I really hope that's volume. Frosting would be more surface area, but hopefully we don't have a cake ball full of air. So I'm going to use the volume formula here. So volume of a sphere would be 4/3 pi r cubed. So the volume is 100 pi. So I have 100 pi. I don't know the radius. I'm trying to find it. Equals 4/3 pi r cubed. Now, if you have a pi on both sides, you can just take it out, which is what I'm going to do. So now I have 100 equals 4/3 r cubed. Remember that the opposite of 4 over 3 would be 3 over 4. So now I'm going to get rid of that part. So now I'm going to do times 3/4 times 3/4. And 100 times 3/4 would just be 75 equals r cubed. Now this is where we get into something that you may remember, maybe not. But if I have r cubed, if you have r squared, you do a square root. But if you have r cubed, you do what's called a cubic root. So if you have r cubed, you do what's called a cubic root. And a cubic root looks just like this. It's kind of like a square root, but they put a little 3 in there. And in order to access this in the calculator, I'm going to press the math key and then I'm going to press 4. So anytime we have a volume problem where we're working backwards with a sphere and we have cubed, in order to undo that, I'm going to have to do the cubic root. So now that I'm here, I'm looking for the radius and going backwards. I'm going to go to the calculator. I'm going to press the math key, which is in the top left. Press the number 4, so I have that cubic root. And then I'm going to type it in, so it's the cubic root of 75. So that's what I'm trying to find, is the cubic root of 75. I just want the radius, so I'm undoing it. I have to go backwards. And then I get that the cubic root, or the radius, the cubic root of 75 is 4.217. So let's just say 4.2 units. Now, this can be a little bit tricky for some people because we're going backwards, so we have to be a little bit more careful. You've seen a square root before, but you can do a cubic root. It's just remembering how to access that in the calculator. So let's do another one where we go backwards for some practice. A regulation-sized basketball has a volume of 455.9 cubic inches. What is its diameter? Well, if we can work backwards and get the radius, we can get the diameter. So it talks about a basketball, which is a sphere, and its volume. So, volume of a basketball, volume of a sphere formula is 4/3 pi r cubed. They told me what the volume was. It was 455.9. So 459.9 equals 4/3 pi r cubed. Now, this one's different from the last one because the last one had a pi and a pi, so they cancel out. This one only has a pi on one side, which means I'm going to have to go through this process of dividing pi and taking it out. Remember, if I'm going backwards and I just want r by itself, I'm trying to get rid of everything else. So it's some dividing, some taking things out, taking things away. So 455.9 divided by pi. So if I go type that into the calculator, so 455.9 divided by, I press that pi key, I get 145.11, so I'm going to say 145.12. All I did was divide out pi because I didn't have it like I did before. Like before I had it in both sides, now I don't, so I have to actually divide it out. Okay, so now I'm here. Think back. What did we do to get rid of 4/3? And that was, we did the opposite, so we multiplied by 3/4. So 145.12. And I'm going to multiply that by 3/4. So times 3/4. And we get 108.84. So that gets rid of that part. So now I'm pretty much down to the r cubed part. So now I have 108.84 equals r cubed. Now remember, we just went over this. To get the radius, if it's r cubed, I'm going to do this cubic root thing by going calculator, math 4, and then typing in that number. And it should give me that the cubic root is 4.77-ish. So I can do that squiggle for approximately. Okay, so that's the radius, but the problem asks for the diameter. So what's 4.77 times 2? Well, 4.77 times 2, because that's the radius, that's the half, times 2, would be 9.54. So the diameter of this particular sphere would be 9.54 inches, and that's it. So being really careful as we're going backwards on problems like this, if you want to put this on your colored formula chart, so you just remember how to access that cubic root when going backwards, that would be a great idea. So I'm going to let you put that on your colored formula chart, and then we're going to pick up with these last 3 problems in the next video. See you in a bit.